We're going to continue working on solving rational equations. And again, rational equations are just equations that are represented with fractional parts. So here's our first rational equation that we'd like to solve. Remember, it's very important to check your solutions. One, not only to make sure that you've done the solving process correctly, but two, you have all parts of your equations defined. That means, especially when you're working with fractions, that you are not having a zero result in the denominator, because we know something divided by zero is undefined. So let's get started. Taking a look at our equation here, we want to double check and start looking how we can undo it to solve for our variable x. And so x we notice here in the denominators. And check each denominator, make sure, are they in their most basic parts? Is it fully factored? X plus 3 is, and so is 2x minus 1. Now denominators mean we're dividing by that amount. So in order to undo the division, we're going to have to multiply by that amount. So here, since we're dividing by x plus 3, we're going to have to multiply by x plus 3. Since we're dividing by 2x minus 1, we're going to have to multiply by 2x minus 1. So the common denominator, what we're going to be multiplying by, is both of those pieces, x plus 3 and 2x minus 1. So again, when we multiply fractions, we multiply across numerators, denominators. So I'm going to take that and multiply by each piece of my equation, which results to this. Now at this point, we have to look to see, are there like things to divide out? That was the goal, to undo that division, right? So we can see we have an element of x plus 3 in common here on the left, and 2x minus 1 on the right. We know something divided by itself is 1, so if we divide out the x plus 3's, we're left with 4 times 2x minus 1. If we divide out the 2x minus 1's, we're left with 10 times x plus 3. Well, 4 times 2x minus 1 would be 8x minus 4, and 10 times x plus 3 would be 10x plus 30. Now we've got a linear equation that we can solve for x and keep undoing like we normally do. So I could subtract 8x from each side, subtract 30 from each side, and divide by 2. X should be a negative 17. Now we should check and make sure it's correct and everything's defined. So putting it back into the original equation, following your order of operations to simplify, and putting it in fully simplified form. So what can we divide out here? We've got a set of 2's we can divide out, a set of 5's we could divide out from those common factors. We can see that it's balanced, and each part of that equation is defined.